I recently replaced 2 camera tripods of mine with newer models, but instead of just storing the old ones somewhere safe, I wanted to create something useful with them. So in this 2-part video series, I will show you how I created a battery-powered, motorized and sturdy camera slider that can move my DSLR camera with an adjustable RPM, aka speed, on a specific time from right to left in order to create time lapses. Let's get started. First of all, we need some kind of blueprint. In my opinion, the design should consist of 3 individual boards. The left and right one will be stationary and thus need a thread in order to attach them to the quick release plates of the tripods. The right one will also host the stepper motor with pulley, the main electronics, and finally a limit switch which, once pushed, will automatically reverse the rotation direction of the motor. The left plate also requires such a limit switch as well as a hole for a 5mm screw, which will later carry 2 flank ball bearings to complete the timing belt system of the motor. Last but not least, we have the center movable platform, which will attach to 4 linear ball bearing slide bushings that will ride along 2 guiding tubes. So obviously those have to be attached to the right and left board as well. To finish the blueprint, I added another thread in the middle of the center board for tripod ball heads and 2 5mm holes next to it to later complete the timing belt system. With those guidelines in mind, I then created a more appropriate true-to-scale vector graphic with Inkscape, which determined the final dimensions of each piece. So I got myself the most important material of this build, 6mm thick aluminum. After marking the outline of the 3 pieces with a scriber, I secured the material with 2 clamps and used a simple metal saw to saw along those lines. Once all 3 boards were complete, I used the file to round off all the edges and corners, which left me with a pretty decent result. So I printed out the previously created drawings, used the box cutter to remove the excess unnecessary paper around them, and glued each of them to the designated board. With the templates in place, I started creating indentations through the help of a prick punch and a hammer in the middle of the drill holes of the smaller stationary boards, and afterwards used a 3mm drill to create all the holes. But obviously I then extended the 5mm hole to a diameter of 5mm and the thread hole to a diameter of 8mm. At this point, it was time for my 3/8" tap set to create the necessary threads. By utilizing all 3 of them, patience and a bit of oil, it was actually pretty simple to create a decent thread. So it was no surprise that the 3/8" to 1/4" adapter did fit in the end, which is necessary to connect the quick release plate. Afterwards, I positioned the limit switch in its designated spots, marked its mounting holes and drilled them as well with a 3mm drill. I then repeated the same prick punch marking, drilling, thread cutting, limit switch positioning procedure with the bigger stationary boards and moved on by creating the indentations for the movable platform. This time I used a 4mm drill to pre-drill all the holes except the 2 ones next to the middle one, used once again an 8mm drill and the tap set to create the center threads in order to attach the 3/8" connector for the ball heads, and checked whether the 5mm screws were too close to the ball heads, which was not the case, so I created those holes as well. To finish the board's treatment, I positioned the limit switches once again, determined the spot for 2 4mm screws which will later activate the limit switches, drilled those holes and finally deburred all the sharp edges of the holes. Next I marked a square around the 5mm holes of the movable platform in this manner, which will be mandatory later on for the timing belt system. I marked the dimensions of this required piece onto a 4mm thick piece of aluminum and created the shape through the help of the metal saw. But before attaching it though, I brought in 2 2-meter long hollow stainless steel pipes with an outer diameter of roughly 8mm and an inner diameter of 5.8mm, perfect for the linear ball bearing slide bushings. I cut both of them to a length of 124.5 centimeters, again through the help of the metal saw, and afterwards clamped them on top of the longer stationary plates in their designated spots. Then I used a 3mm drill to create markings onto them from the other side of the board and used those as a guideline to completely drill through both pipes. Next, I removed the protective film of the center plates and secured all the linear ball bearing slide bushings with 4mm bolts, while making sure that an identical sized tube connects parallel bushings while tightening the bolts. After removing the protective film of the stationary platforms as well, I pushed the two stainless steel pipes through the bushings of the movable platform and secured the pipes with M3 bolts, washers and nuts to the one board with already drilled holes. I then positioned the other boards precisely on top of the pipes, secured it in place with clamps and used a 3mm drill once again to mark the correct spots. Just like before, I then completely drilled through both pipes and secured them to the board with bolts and nuts as well. Lastly, I screwed in the thread adapter and secured the quick release plates to both boards, which basically completed the mechanical builds. That means that this slider can already be used by hand. But what I immediately noticed while trying it out is that it does not slide very smoothly, because the pipes do not have a constant diameter of 8mm. And it was also noticeable that self-locking nuts are kind of mandatory for this kind of builds. But nevertheless, stay tuned for part 2, where I will motorize and automatize this build. Until then, let me treat those pipes. And as always, don't forget to like, share and subscribe. Stay creative, and I will see you next time.